Digits A and B are selected to form the number AB. For example, if A is equal to 3 and B is equal to 6 are selected, they form the number AB, which is equal to 36. Digit A is randomly selected from this particular set that contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And digit B is randomly selected from this set, and the set contains the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It says, consider 0 to be an even digit. Draw and complete the diagram. Draw and complete the tree diagram. And so here we have this tree diagram, and our goal is to complete it. Let us call this set, we're going to call this set A, and we're going to call this set B, all right? And so our goal is to figure out, okay, if we want digit A to be an even number, if we want digit A to be an even number, what is the probability that digit A is going to be an even number? Well, let's count how many numbers are in set A. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 digits in set A. So there are 9 possible possibilities, right? So there are 9 digits to choose from. So we're going to put 9 at the bottom. But how many of those digits in set A actually are even numbers? So we have 2, that's 1. We have 2, we have 4, we have 6, and we have 8. And so that's 1, 2, 3, 4. So there are 4 even digits, right, in set A. So that means that the probability that digit A is going to be an even number is going to be 4 over 9, because there are 4 even digits in that set, and there are 9, there are a total of 9 digits inside of that set. And so it's going to be 4 over 9. Now, we need to figure out what is the probability that digit A is going to be an odd number, right? What's the probability that digit A is going to be an odd number? Well, we ask ourselves what is the total number of elements in that set, or what is the total amount of possibilities, right? The total amount of choices, right, that we're able to choose from. And the answer is 9, because there are 9 numbers, right? 9 numbers, 1 through 9. All right, so, but the question is, how many from those 9 numbers, how many of them are odd? And so let's count how many odd numbers we have. This is 1, this is 2, this is 3, this is 4, and this is 5. There are 5 odd numbers. And so since there are 5 odd numbers, the probability of digit A being an odd number is going to be 5 over 9, because there are 5 odd numbers, and we have a total of 9 numbers in total. Okay, so now we go into digit B. So the question is, okay, I want digit B rather, to be an even number. What's the probability of digit A? I'm sorry. Here we're focusing on digit B. So we ask ourselves, okay, what's the probability of digit B being an even number, right? What's the probability of digit B being an even number? And so we go to the set, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, right? 10 digits in set B. And so that means that we put 10 at the bottom, because there's 10 possibilities. There's 10 choices overall, okay? So, but we want specifically for B to be an even number. So let's count how many even numbers we have in this set. This is going to be 1, 2, 3, 4, and 5. So there are 5 even numbers in the set. So there are 5 even numbers in the set, and there are a total of 10 numbers in general, or in total. And so the probability of digit B being even is going to be 5 over 10. Okay, 5 over 10. Next, we want the probability of digit B being odd. The probability of digit B being odd. Okay, so, all right, the probability of digit B being odd. Well, we know that there are a total of 10 digits in this set. So there are 10 digits in the set because we go from 0 to 9. How many odd digits do we have? How many odd digits do we have? Well, we have 1, we have 3, we have 5, we have 7, and we have 9. So in total, how much is that? That's 1, that's 2, that's 3, that's 4, and that's 5. So there are a total of 5 odd numbers inside set B. So set B contains a total of 10 elements, but 5 of them are odd. So that means that the probability of digit B being odd is going to be 5 over 10. Okay, let's move on. So here we still have digit B, right? What's the probability of digit B being even, right? What's the probability of digit B being even? All right, what's the probability of digit B being even? We already found that out. The probability of digit B being even is 5 over 10, all right? Same thing for this one. What's the probability of digit B being odd? That's 5 over 10 as well. So the probability of digit A being even is 4 over 9. The probability of digit A being odd is 5 over 9. The probability of digit B being even is 5 over 10. And the probability of digit B being odd rather, is 5 over 10. The probability of digit B being odd is 5 over 10. And the probability of digit B being odd is definitely, the probability of digit B being even is 5 over 10 as well. And so we have completed the tree diagram. Quick recap, the probability of digit A being even, 4 over 9. The probability of digit A being odd, 5 over 9. The probability of digit B being even, 5 over 10. Digit B being even, 5 over 10. Probability of digit B being even, 5 over 10. And the probability of digit B being odd is 5 over 10. And so let's move on to the question. It says, calculate the probability that both digits in the number AB are even. And so if both digits are even, that means that digit A is even, all right? And so that's just why we have 4 over 9. And digit B is even. That's going to be 5 over 10. And so that means that we go in this route. So we have that, let me use a highlighter. We have that digit A is even. That's why we use 4 over 9. That's digit A is even, 4 over 9. And then digit B is even. That's 5 over 10, right? We go in this direction. That's 5 over 10. And so that's why we have 5 over 10 here. Next, we multiply. When we multiply, we get 4 times 5 is 20. 9 times 10 is 90. We cancel this 0 with that 0, so we have 2 over 9. So the probability that both digits in the number A, B are even is 2 over 9. And that's the answer to this question. Next, we want to calculate the probability that one digit is odd and the other is even in any order. And so what we have to do is to calculate the probability that one digit is odd and the other is even in any order. So we have to do it like this. So we say, okay, let's say that we want the probability that digit A is even. That's 4 over 9, right? And then we want the probability that digit B is odd. Okay, so digit B is odd, so that's going to be 5 over 10. So 5 over 10 right now. So what does this product, or what does this multiplication indicate? That's going to be 4 over 9 because digit A is even, but digit B is odd. So in this case, A is even, B is odd. Okay, A is even, but B is odd. Now we have to do A is odd, but B is even. And so what's the probability of us getting that? Let me use a different color. All right, let's use a different color. We want a probability that A is even, right? But B, I'm sorry, the probability that A is odd, but B is even. So A is odd, but B is even. So it's going to be A is odd, but B is even, okay? So it's gonna be 5/9 multiplied by 5/10. And so this one, what does it say? This one is A is even, but B is odd. That's what we have here. A is even, but B is odd. And this one is A is odd, 5/9, but B is even. So B is even, 5/10. And so we multiply, we have 4 times 5 is 20. 9 times 10 is 90. 5 times 5 is 25. 9 times 10 is 90. The denominators are the same, so we can add. So we have 20 plus 25, and 20 plus 25 is 45. So we have 45/90, and 45 divided by 90 is 0.5. Next, we want to figure out, it says calculate the probability that the digits produce the number AB is equal to 36. So if the numbers produce AB, which is equal to 36, that means that for A, the number that was selected was 3. And for B, the number that was selected was 6. Now, what's the probability that we're going to get 3 selected from A? Well, it's only one number. And out of how many possible outcomes? 9. So there are 9 possibilities. So it's going to be 1/9. And what's the probability of 6 being selected in set B? Well, it's only 1/6, and there are 10 digits altogether, so it's going to be 1/10. And so we add these two together. When we add them, we get 1/90. Oh, no, that's not right. That's definitely not right. So when we add okay, let's do this the right way. So we have to make the denominators the same. So we multiply this by 9. We multiply this by 9. Whatever we do to the bottom, we must do to the top. We multiply this one by 10. Okay. We multiply this one by 10. And so we have, what do we have? We have 10 times 1. What is 10 times 1? That's going to be equal to 10. Okay. And then 10 times 9 is going to be equal to 90 plus 1 times 9 is 9. All right, all over 10 times 9, which is 90. Okay. And so this is going to be equal to 10 plus 9. Well, 10 plus 9 is 19. All over 90 and 90, they are the same denominators. So we keep them the same. So it's 19/90. Okay. So the probability that the digits produce the number AB, which is equal to 36, is going to be 19/90. And that's the answer to this particular question.